Okay, awesome. Hi everyone. I'm Tunmise Raji. This work was done in collaboration with Courage Ekoh, Dr. Nathan Williams, and Dr. J. Taneja. Yeah. The main motivation for this work has been the significant investment in the transportation sector in sub-Saharan Africa. In the chart on the right-hand side, you will see a lot of money has been going into investing into I guess I'm looking at ways to improve this particular sector in the region. So we hope to develop methods that we can use to assess changes in the quality of road infrastructure. Yeah, the current approach has been with accelerometer. So the current approach is you attach these cell phones to vehicles, and then with that, you can calculate this international roughness index. But the issue with this approach is it's very difficult to deploy at scale. So on the chart on the right-hand side, I'm comparing the previous approach at the top, which basically couples this index with high resolution or medium resolution images, and then feeds that into a machine learning model. And the goal is to classify road surfaces as good quality or bad quality. So we propose a different approach where instead of using this difficult to obtain data, we are suggesting using open source data of road surfaces. And then we also want to combine that with medium resolution images. And then we want to classify roads as paved and unpaved. And the final goal is we can use that classification to actually estimate the quality of road by assessing the share of paved road in a particular country. So the goal is to understand if we can use open source data plus medium resolution satellite imagery to measure the quality of road infrastructure. Yeah. So this chart just gives a brief overview of the task. So the image on the left-hand side shows a high resolution image of a paved, I guess a paved road and also a road that is unpaved. And you can see it's really easy to separate these two road classes. But on the right-hand side, we have the same types of roads, so paved and unpaved, but now we are showing it with a 10 meter spatial resolution data from Sentinel-2. So you would observe that it's really hard to separate these roads as you go to this very, very poor resolution. But the reason we are choosing to use these satellite images in this particular study is because they are freely available. We have a long record of them, and also they have this global coverage. So the goal is to understand if we can use medium resolution multispectral images to classify road surfaces as paved or unpaved. So, yeah, a brief overview on our approach of collecting data. So we got the location of all the roads in sub-Saharan Africa from OpenStreetMaps, and this data set also contains information on the road surfaces of some of those roads. And then for our imagery, we produced the median annual composite of Sentinel-2 and Landsat-8 multispectral images. And our approach was we collected the surface reflectance of every pixel that is intersected by a road. On the next slide, we're assessing the separability of these two classes of roads. So the chart on the left-hand side shows paved and unpaved roads. So we found a way to classify roads based on their surface conditions as paved and unpaved. And then on the right-hand side, we are showing the signature of these two classes of roads. So you would observe this very nice separation between paved and unpaved roads, where we see paved roads having lower surface reflectance values, particularly in the long wavelength part of the spectrum compared to unpaved roads. Yeah. And then passing that data set that we created into a machine learning model. In this chart, we are showing the performance of the model for this binary classification. So basically classifying roads as paved or unpaved. So the chart on this chart shows the performance of a range of machine learning models. So we explored 8 different models in this case. Also, we used balanced accuracy, AUROC, and F1 score to compare the performance of the models. And lastly, we compared two different sources of imagery. So Sentinel-2 at a 10-meter spatial resolution and Landsat-8 at like a much higher, a much poorer medium resolution image. And we would observe that we have this very decent performance across the range of machine learning models. So with Sentinel-2, we are obtaining about 85% balanced accuracy with random forest, while with Landsat-8, we had about 75% balanced accuracy, which suggests that we have like a really decent performance with these medium resolution images in classifying this road as paved or unpaved. Yeah, and in this next slide, we are trying to really validate the prediction of our model and to see if it aligns with reality. So we are overlaying the predictions of the model shown in white text here on historical high resolution images that we obtain from like various sources online. So what you would see if you focus on the first row, the third box shows a particular road where in 2020 that road was classified as unpaved. We can see that actually aligns with the actual reality of that road at that point in time. And then if you fast forward to 2022, we can see that the surface actually has become paved. So the road now appears paved, which also aligns with the predictions of our model. So in a way, we can see that the predictions actually align really well with historical high resolution images. And lastly, we went back to the first question I mentioned earlier, which was, can we use this approach to assess the quality of roads? So we're comparing, so the approach here was, we got data from the Africa Infrastructure Development Index, which basically ranks different countries across their transportation sector. And then we used our approach, which classifies roads as paved and unpaved, to calculate this paved road to total road ratio. So basically the share of road in a particular country that is paved was used to calculate this index. And the chart on the right-hand side shows the correlation between our index and the AIDI. And we'll observe a very strong correlation. So we are seeing a coefficient of about 0.71, which suggests that we're able to perform well in this task of assessing road quality. And also our approach has this advantage of being granular, both temporally and spatially. So you can actually run it at like a village level or a cell level compared to the AIDI that you can only have at the country level. Also, it is temporally granular, so you can run it for multiple periods of time. You don't have to wait for a particular year. Yeah. So in conclusion, in this paper, we showed that we can distinguish between road surfaces as paved and unpaved with medium resolution images, with Landsat-8 and Sentinel-2 satellite images. And then in future work, we hope to use the predictions of this model to understand the evolution of road infrastructure in sub-Saharan Africa, and also to use it to conduct impact assessments to understand the impact of infrastructure developments on local communities. Thank you.
Any questions?
Hello, thank you. My name is Brian from Stanford University. Thank you for the presentation. This might be a dumb question, but in terms of monitoring roads, like could you is one path you're thinking about in the future is to differentiate between a degraded road versus a new road or something like that? Like, can you monitor the degradation of roads, for example? Because in the long-term scheme, if you wanted to replace the infrastructure, it would be pretty useful to have a consideration for that in the long term. Is that part of your consideration?
Yes, so actually right now the current goal is to first see if we can classify roads into these two classes, but then also in sub-Saharan Africa, there are some roads that are paved, but they're actually low quality roads. So I think the next natural extension of this work would be to go beyond just paved and unpaved, to also consider the aspect that you brought up, right? So the way paved roads could actually degrade in a way where they become sometimes even worse than your natural unpaved roads. So I would say that would be like a natural extension to this work would be to explore those considerations.
Okay, thank you.
Okay, thank you.
you.
So let's thank the speaker again.